All right, so in this lesson, I want to talk about how one term may imply another term and what that means in logic. So this is going to look like this when we write if P then Q. We have had this before in categorical logic when we were talking about logical fallacies, but now we're going to understand this formula a lot better. If P, then Q. The U, sometimes we talk about as the horseshoe or the sideways U, is just a symbol that we say one implies the other. Or in other words, whenever there is a P, there is also a Q. That's all that means. I'm going to take out that underline so it doesn't look like a slightly different symbol. Whenever there is a P, then there is a Q. That's what we mean by if P, then Q. We could symbolize this a number of different ways. We could say, if I eat too much, then I will be full. That's all that we're really doing here. So, if P, then Q. This is going to bring about an interesting question, though. As we've been seeing with truth tables, we've been trying to take an entire proposition, which this would be a compound proposition in the same way that either not P or P and Q would be compound propositions. So too, if P then Q would be a compound proposition. So let's think about what this would look like. If I set up my truth table, I have P, I have Q, and then I have if P, then Q. So for my last one, remember I start with, I'm going to do 2 to the nth power, which in this situation is 2, and so I'm going to have 4 different set of possibilities. And so P, we're saying P is true, and we're saying P is false, and we're saying Q is true, false, true, false. If that doesn't immediately make sense to you, go ahead and look at the last video that that I posted on this. Okay, I know it's really hard to see in this rather dark room, but if I turn the big lights on, there's such a glare on this whiteboard that doesn't work. If P then Q, well, let's think about this. This state of affairs would be true if P is true and then Q is true as a result, right? Oh, this is if P then P, which is tautologically true. Pardon me, if P then Q. This would be true. So if P is true and Q is true, we can say if P is true, that whole set of propositions is true. Similarly, if I was to say P is true and Q is false, this compound proposition must be false, right? Because I have P, but I do not have Q, and so it must be false that if P, then Q. So far, so good. And that's relatively straightforward. So let's think about it this way. If the state of affairs is if I eat too much, then I won't be hungry, pardon me. Even though that has a negative there. And it's true that I eat too much, and it's true that I'm not hungry. Okay, we can say that state of affairs works. But if it's true that I eat too much, and then it's false that I am not hungry, then it seems like we have a problem here. And so we can recognize that whole state of affairs is false. Again, so far so good. But what happens when the premise is false? Sometimes we call the proposition on this side of the if P then Q the antecedent. I'll just put antecedent. And the Q the consequent. Antecedent, consequent. So P would be the antecedent, Q would be the consequent. What happens when the antecedent is false? It's not as obvious, I'll let you know. The book has actually a really helpful example that I'm just going to go ahead and read straight from. It says, if a poodle is a tiger, then a poodle is a mammal. Well, that's kind of weird because a poodle being a tiger is false, but a poodle being a mammal is true, but there's no clear relationship between those two things. And so we might kind of scratch our heads and say, I don't know what the actual full proposition if P then Q is on its own, right? Because I could also have an instance which would say something like this. If a poodle is a tiger, that's false. Then a poodle is a dog. That's also false, right? And how in the world, oh, pardon me, the poodle is a dog, that is true. But how in the world, what is the relationship between those two things? It doesn't seem like there is a relationship between those two things. And so how do we determine if the if P then Q is true or false? It's actually probably going to surprise you that we would say true for both of these states of affairs where the P is Q, where the P is true and the Q is false. So you might say, well, why is that? How in the world can the proposition if P then Q be true when the antecedent is false? What sense does that make? In order to understand that, you need to understand what this relationship actually is. In a roundabout way, if P then Q is actually equal to an entire state of affairs. And that state of affairs is not just, well, here, I'll write it out. That state of affairs is more or less equal to not P and not Q. Think about that for a second. If P then Q is the same thing as not P and not Q, where P is true and not P is true, then if P then Q is false. It's word salad, isn't it? Honestly, sometimes it feels like you're just garbling out letters sometimes. So let's put some variables in there to make more sense. It's not the case that if I am hungry, or let's make it what I had before. If I eat too much, and I am not full. Okay, so I have, let's say, P stands for I eat too much or I ate too much. Q stands for I am full, not Q would be I am not full. And so if P then Q basically means that you cannot have these two things true at the same time. Okay? Let's think about what that would look like in a truth, with a diagram of the truth values. So let's say not P and not Q. First and foremost, what we're going to want to do is we're going to find the variables. I'm going to just jump ahead on this one so that we can continue with the same truth tree diagram. We'll say not Q. We're interested in figuring out what not Q is. Remember, we're just going to look over at Q, and where it says true, we write false. Where it says false, we write true. Where it says true, we write false. Where it says false, we write true. Okay? Now let's look at the whole proposition. P and not Q. That whole proposition, now we're just adding this not Q, and we're saying that has to be true. So it's automatically going to be false wherever it's false here. And on top of that, the P has to be true. Okay, so now we have P and not Q. But remember, we're looking for not P and not Q. And if we look at that, that just means that wherever it's false here, it's going to be true on the other side. So we'll say not P and not Q. So we're just going to negate this line right here. We negate it, and we have true, false, true, true. Well, if you recall, that's exactly what we have over here when we say if P then Q. And so when I use the expression if P then Q, that's actually just shorthand for writing it's not the case that P and not Q. And again, I recognize that this board is really difficult to read in these videos, so I apologize for that. So I'm going to take a moment here and just kind of look at everything. We have P, Q, if P then Q. And we decided the truth value chart looks True, false, false, true, true. True, false, true, true. How did we get that? Well, we recognize that when I say if P, then Q, I'm actually saying it is not the case that P and not Q will be both true. And when I diagram not P and not Q, which I did over here as well too, I first start with not Q. I then figure out P and not Q. And then finally, last but not least, I can figure out not P and not Q, where the first not is outside the parentheses. That's how I get true, false, true, true. And so I can determine going all the way back over here, P, if P then Q, is equal just to simply true, false, true, true on this chart. That's going to be, it's hard to articulate how important that is later. We're going to come back to this in, 3-4 weeks or so. Maybe even longer than that. And you're going to have forgotten this. Trust me, it's the case. And yet, when I re-review it, I want it to be like, oh yes, I do remember going through that. So if this doesn't make sense, go through it again. Look through the chapter again. And remember that we're dealing with the same expression, if P then Q, as not P and not Q.